Hello viewers, hello to everybody in the world joining us for this live event brought to you by Frequentis DFS Aerosense. I've seen there are a lot of registrations and a lot of people are joining us on this call today, and that's pretty cool. We have seen people from New Zealand, Australia, Asia. We have registrations also from Europe, from North America, South America. So it seems this topic gets a lot of attention and a lot of interest. Looking back to remote tower, and that's the topic for today. It was first invented and the first concept was drafted back in 1996 by a team of German researchers. Now, some decades later, we are really in a phase where remote towers gets even more important. We are in a situation where contingency, where resilience is paramount, and there remote tower can definitely help. We are talking today about the German project by the German ANSP DFS, Deutsche Flugsicherung, where remote tower has been deployed now for more than 2 years. So back in 2017, the concept was tested, validated with controllers, and end of 2019, it went into operation, in live operation. In regular times, they are managing about 15,000 flights at Saarbrücken Airport remotely at the Leipzig center. And there are no controllers any longer in Saarbrücken. They are all working from Leipzig, which is about 450 kilometers away. Saarbrücken is one of many remote tower deployments from Frequentis and from DFS in the world. There are installations in the British Isles, in Jersey. There is installations in Vienna, Austria, in Iceland, in the US, in Argentina and in Brazil. So this is just a few examples of where this technology is today. So today we have a really interesting program ahead of us. I have a couple of really good speakers. So also for us, it's important that we have a lot of interaction. But first of all, if you like what you see and hear, please make sure to hit the like button on YouTube, subscribe to our YouTube channel to be updated for further content, and check out our website, aerosense.solutions, to get more information and also the possibility to contact. So how do we do with questions today? For the questions, we have implemented a Slido event with the code 5229. If you go there, you can post questions which the experts will answer at the end of the session. So I hope we get a lot of questions, and I hope we can have enough time to answer all of those questions based on your interest. So, coming to the speakers today, I'm really proud to have 3 extremely good speakers, 3 experts in the area with me today. So first, it's Dirk Mahns. Dirk Mahns is the Chief Operating Officer of DFS in Germany. Andreas Willmann, he is the supervisor of the Remote Tower Center, and he will be also talking to us today. And from Frequentis, we have Peter Griedling. He's also the VP Sales for Frequentis DFS Aerosense. So, with that said, I would like to go to Dirk Mahns. And let's see, let's switch now to Frankfurt Langen. Hello, Dirk. Hello, how are you today?
Hello, everybody. Well.
Very good, very good. So, great to have you here. So, of course, DFS, you were really pioneering with this project. I think back then when you first thought about the idea of remote towers, it was really an unprecedented case. You were one of the first ANSPs go live with such a system, or starting a project actually. So when did DFS start to think about the remote tower center, and what was the schedule of the project?
DFS initially started investigating remote tower operations in 2010. Together with the German Aerospace Center, we set up a research project and conducted a human factor study to analyze the influence of remote tower operations on air traffic controller and on their procedures, etc. This study scrutinized the visibility of the planned operations. That was very important for us, that we see really there's a case for us, an operational case. And then in 2015, DFS started developing the remote tower solution together with the Austrian high-tech company Frequentis. It was a very interesting, very challenging project. We had a tough time schedule, and we are in operation now since 2019.
That sounds pretty good. So from a perspective of DFS, I'm sure you made up plans of benefits. You wanted to, I'm certain you had to have some perceived benefits. So what is actually coming out of the project? What did you gain as an ANSP in implementing remote towers?
Yeah, we have a lot of benefits. What we see here, first, there was the good situation for us for this project that we had an old tower which needs to be replaced in Saarbrücken. So for us, sure, it was a case that we do not need a tower anymore. We do it out of a remote tower center with all this technology, which is cheaper than building up a new tower. In addition, it is possible for us, and that is the future vision, that we can organize our operational staff in a better way, so that we have there a cost efficiency impact, a huge cost efficiency impact. We can reduce the operation and maintenance cost by using a uniform infrastructure for several towers. So overall, in summary, it's a good project from my point of view, which aims to reduce overall costs for operation technology and for buildings. In addition, and this is one of the major impacts which we have seen, is that there is as well the opportunity, the chance of a job enrichment for ATCOs, for air traffic controllers, who work then for several airports instead of working only for one airport.
Okay, so that sounds interesting. You talked about Saarbrücken. So can you describe the scope of the project, about what has been implemented and where, and how it was done?
Yeah, first we moved tower operations to a remote center from Saarbrücken to Leipzig. We would like to integrate two additional airports at this remote center. That's Erfurt and it's Dresden. We have their plan to do this in the next years, 1 or 2 years. And then we have 3 towers remotely in one center. And I think this is the plan which we have now first covered in a project. And sure, there are other opportunities in the future. But we look at first at this other opportunities when this huge project is finished with the 3 airports.
Okay, thank you, Dirk. So we will come back to you later, and I hope there will be also questions more. So a reminder again, if you want to participate in the conversation, get interactive, go to Slido, www.slide.do, and enter the code 5229. We are now switching to Leipzig, where Andreas Wildmann, the supervisor of the Remote Tower Center, will take us on a tour through the Remote Tower Center there.
Welcome to the RTC at Leipzig. I'm going to show you the working positions, the different ones we have in that room. At your right side, you can see the working position of Saarbrücken we are currently using. The next one to the left is the working position, is a redundancy working position, that which is now switched to the systems of Erfurt, but we don't have an outside view from Erfurt yet. Well, we can switch over in case of we need a redundancy. Switch over to the systems of Saarbrücken, and then we can switch on as well the outside view. That should be there within a couple of seconds. Right now, this working position could be used for Saarbrücken. The next working position at the left side, this is Erfurt. That one, that is the primary working position, of course, for Erfurt. You can see the ATS systems, but of course no outside view, because till now no cameras at Erfurt. The next one to the left is Dresden. That is planned a bit later than Erfurt, about 1 year later. And as you can see, there are no screens installed. There are no cameras at Dresden. I guess it will come next year. Well, the working position we are currently using, you can see on top the screens for the panorama view. Presently it is switched to the normal video picture. You can turn it around, not turning your head as you did on the tower, and just now turning the mouse wheel, and then you turn the whole tower into the direction you need. What you can do is switching over to infrared. That is very useful for darkness, during night, or even it just shows you more details during the night. You cannot see only the lights of the aircraft. You can see the whole fuselage, the whole silhouette of the aircraft during night. On the video screen, you see these triangles down here. They're showing you where the PTZ, the pan-tilt zoom cameras, are currently looking. If they come up into the screen, it changes over. It's such an eye that shows you where the camera is looking. What the camera sees, you can see down there on the screen, or even on the vacuum screen. And the vacuum screen is used for directing the cameras. Just using a finger on the screen, moving it into a direction, the camera will follow that direction and stops when you get your finger away. And what you can do as well is switching the camera to hotspots. That means with one tap on the screen, it goes to a predefined position. You can as well use the camera in an automatic mode. That means marking an object, and now the camera will follow automatically that object. In the panorama view, we have an overlay function that is very useful for work they've got on the runway, or even for the runway checks. You can mark the runway as blocked, and then it is written on the screens that it is blocked, and I get that red band over there, that so you'll never forget anything on the runway. As well, you can use it for reduced runway separation. We have marked the points of 600 meters and 1,500 meters. For runway 27, we can see now that you can use for the reduced runway separation. As well as switchable for the other direction. Oops. Now you got it for runway 09, 600 and the 1,500 meters. So I hope I've given you a short, rough overview of what we're doing in the RTC right now and what will come up next years.
So that was pretty interesting views from Andreas Willmann showing the remote tower center. I would like to give him the chance now to settle there and get ready for the further interview and for the questions before we are switching back to Leipzig again. It's really great to do this actually live, even though we have all the restrictions and travel restrictions going on. But we can see we have a good team here that is doing the production here and bringing live to you some really interesting content. So let me check with if we are ready in Leipzig again, and if we can bring Andreas Willmann back. Okay, here we are again. So pretty cool tour that you gave us there, Andreas. So from how you were doing, what were the main differences in working in a conventional tower and a remote tower center? I don't know. Is it very different, or is it similar, or what did you think about it?
Well, it's similar but different. I think the major difference between the conventional tower and the remote tower system is that you no longer can turn your head to see an aircraft like you can do in a conventional tower. You turn around and you're aware of the position of the aircraft. Now the difference is that you have to turn the whole tower instead of it. It's not a very hard work. It's easily done by turning just the mouse wheel. So you're rotating the outside view to the direction you need. And you can switch on PTZs instead of using binoculars. And this is quite different because you're steering your view on a touch screen and not by taking the glasses and looking out. And so the difference is to get aware of or to get your traffic picture. That means you're picking pieces of information on different screens instead of turning it judiciously ahead and seeing the position. So now you have a screen right in front of you where you see the aircraft flying, but what we see is an aircraft flying in front of a blue sky. That gives you just a piece of information, because you see now the aircraft that is flying straight ahead. It's not climbing, it's not descending, but nothing more. You're not aware of the position. So, so you have to turn around and see on the panorama view. That's a kind of an eye you see where that camera is looking at. So that means seeing the aircraft flying in a direction that it is flying straight, and then looking at the screen at the panorama view, and seeing that where the aircraft is. That means getting pieces of information together.
So that's quite important, I'm sure, to get the situation awareness. I'm sure you had to do some kind of training actually to get used to the system. So how did you train to work with the new setup in Leipzig now?
We trained that in two different ways, parallel but two different ways. It was the first thing was a simulation. The whole training started with a simulation session that was aiming just to get you used to the system, to let you know what the buttons are for, and how to direct your view, how to use the cameras, how to turn the panorama view, and all the features that are now implemented in an artificial view instead of the live view. The other part was training in shadow mode. Shadow mode training was a training that was just observing the actual traffic that is handled by a colleague that is on the live tower, and you sat on the working position or the RTC working position, and you're just following the traffic. That means just directing the cameras, following the traffic, and trying to keep the picture, and listen to the guy upstairs, and just following the picture, getting aware of that, and using the cameras of course, in due time. And the next was as well a simulation session in the middle and in the end. That means the very beginning of that simulation was, of course, a run where only a few aircraft are. So really aiming for the handling, for learning the handling, and not handling traffic. And later on, the last run really was with a lot of traffic, getting aware that what number of traffic you can handle with that system for everyone. And after that, it was quite a kind of checkout, showing that everyone is able to handle the system. Not to handle the traffic, but is able to handle the system.
Sounds pretty interesting, actually. So let's go a little bit more into the technical side, and for this I would like to invite Peter Grieling on stage. And Peter has been also with Frequentis for a lot of years and is now actively working for Frequentis DFS Aerosense. So, and he's really a renowned expert on the remote tower side. So, Peter, where do you see the remote tower technology going if you look now 10 years ahead?
Well, when I'm looking 10 years ahead, I believe that remote tower technology will be in place in every airport worldwide, regardless if it's a large hub airport or even the smallest airfields. Of course, there will be different use cases, so we will see real remote tower technology on small airfields. We will have vision enhancement and large airport operations on hub airports, and we also will see a lot of regional airports which will be either have remote tower technology implemented as a remote tower, or also for the contingency use case. Think about natural diseases or other threats like a pandemic situation like that, and in all those different situations, remote tower technology can support the controllers and the ANSPs to do their daily work, basically.
Okay, so I know Frequentis is very active in research and development and very innovative. For instance, there is projects in the European program CESAR. So what's on the roadmap for innovations going further? What's the steps further now?
Yeah, one of the biggest topics for us in the near future is definitively the multi-remote tower control. So here we are talking about the possibility that one single air traffic controller can handle up to 3 airports simultaneously. There are different concepts implemented to do it simultaneously or to switch between different airports. Also, a big topic will be artificial intelligence, the support of the air traffic controller in the daily work by artificial intelligence, by doing analysis, by classification of objects automatically, and to provide additional features which basically support the air traffic controller in the daily work to reduce workload on one side and also to enhance safety on the other side. A big topic will be drone integration and drone detection. So drone threats are a huge topic in these days, and the near future we will have to find a solution how to integrate drones in the normal airspace. And of course that also affects remote tower. So there we clearly address the integration of the UTM space and also the integration of drone detection systems to avoid issues in the future with drones.
Okay, I'd like to go back to this multi-remote tower that you mentioned there. I know that you've done trials within the framework of CESAR with research, human factor study side to it. Is there certain things that are integrated there? Are there certain things that are different than on a regular remote tower now?
Yes, exactly. So basically, when we are talking about multi-remote tower, then it's about reducing the workload. And the workload can be reduced by integrating different ATC systems into the environment of the air traffic controller so that automatic data exchange is given or that automation itself can be realized between the different systems. And here we are especially working on the integration of voice communication. So we have seen in the past that the integration of voice communication is essential to reduce the workload for the controller so that the controller always keeps the situational awareness at the right airport. But also the integration of other ATC systems like approach systems, like ASMGSs on larger airports, or the integration of runway lighting control systems and MET information directly in the field of view of the controller.
Pretty awesome. I see that there is a lot of questions already coming in, so final questions for you at the moment, and then we go back to Dirk. In 2018, Frequentis and DFS, with DFS Aviation Services, you signed a joint venture called Frequentis DFS Aerosense. What are the current projects that you are working on right now?
Yeah, we have been pretty happy to found this joint venture. So basically the intention was to combine the technology of Frequentis with the operational expertise of DFS. And the first project we have now won at the beginning of this year was the project at Naviair in Denmark. So here at Billund Airport, we are implementing the next generation of remote tower, not only covering the topic of tower control, but also approach control. So here in this project, we have the challenge that during the day, we have a splitted position so that one controller is handling the tower control and one controller is handling the approach control. But during the night, that should be combined so that one single controller does the tower control and the approach control at the same time. And therefore we have combined our remote tower technology with our product Phoenix out of our Frequentis family Comsoft to integrate that in a combined solution.
Okay. Let's go back to Dirk, and then we go into the question round. They're coming in. There are a lot of interesting questions coming in. Dirk, let's take the view of a pilot now. Let's take the view of the airspace user, which is your customers actually. What do they think about the ATC service being provided remotely? What do the airspace users and the pilots think about that?
Yeah, I think what was important for us when we started the project was that we involved very closely from the beginning on the airlines and the pilots to receive a feedback about our operation with remote tower. What was then, I think the surprising issue was that it was quite transparent to them what we are doing there. That means there was no real difference for the airlines and for the pilots regarding the operation from our tower controller. They receive the same professional, safe and fluent air navigation service as today, and which they had before in Saarbrücken. So I think from our point of view, there's no difference, and with some advantages regarding cost benefits here.
Okay, so nothing really changed for the airspace users. Taking a look at the other stakeholders here in aviation, what are the benefits for an airport or an airline of this technology?
I think the major advantage is that it is possible for us, for the service provider, to reduce costs for the service, and that means we can reduce charges for the airports or for the airlines. I think this is a major point. And once we have all 3 airports in operation out of the center, we see that we will have a significant positive cost impact regarding remote tower services, which we then can forward to our airspace users and airports.
Okay, so basically you mentioned the 3 airports. So what's the plans now? I think you mentioned it briefly on the beginning, but what is the concrete plans now? Saarbrücken was the first now, which is now controlled in Leipzig, and Andreas took us on the tour. What's next?
Yeah, what I can tell everybody, the first one is the most difficult one. Yeah, so I think we achieved Saarbrücken. That's good for us. Now the plan is that we has as in our plans that this year we have the site acceptance test for Erfurt, that we are in operation with Erfurt in the next year, and then in 2021, and in the year after Dresden. Then we have 3 airports in operation and the remote tower control center of DFS, and then we see what we do next. We have a lot of good ideas for the future. I'm sure because everybody is observing what we are doing, and it's quite successful. And so I'm looking forward to have a nice and good future with remote towers.
Absolutely, and I can confirm it's really pioneering. I mean, we just recently had a digital tower user group with customers from around the world, and the experience that you had was really great to share, and the others were listened in. And I think it's good generally for us as an industry to collaborate, to share, to learn from the experiences. I think you really did pioneering work with Saarbrücken, but now it's really up to roll it out and get it rolled out in Germany, but also worldwide. So thanks, Dirk. So let's take everybody on stage now, because I have a lot of questions in the Slido already, really interesting ones, and I'll go through them, and I'll see a lot of they're mixed, they're operational, technical, and I'll go through them. Let's see how many we can answer. So the first one, it's maybe a more easy one for Peter. How do you handle radio failures and respective light signals?
Well, when there's a communication issue with an aircraft, then we have an integrated light gun into the pan-tilt zoom camera. So basically, when you target the pan-tilt zoom camera to the specific airplane, then it's also guaranteed that the light gun is seen by the pilot and that he receives the specific signals.
Okay, I see. I have the code here again. Slido 5229 is the code for questions. Yeah, we have it now on. Great. So in case you want to have more questions. Let's continue with the cameras again. What is the backup for a camera failure?
Well, the backup for the camera failure, there are multiple redundancy features implemented. So basically, you can have a double redundant fixed camera cycle. Also, the PTZ camera, so there are always 2 PTZ cameras in the system, and for example, one PTZ camera can replace one of the fixed cameras, so you have still one PTZ camera replacing the binocular, and the other one then being a redundancy feature. And if there is really a major issue, then it's an operational approach of redundancy. Then you go back to low visibility procedures, and then handling the traffic under these circumstances.
Okay, thank you, Peter. The next question is related to training. I don't know if Dirk or Andreas would like to answer them. that question. So how long does it take for an ADCO to be qualified in this remote tower control center? Do you have ADCO assigned to your center just after the academies? So, Andreas?
So yeah, sorry. Yeah, it took for the controller that happened at Saarbrücken and moved with us to Leipzig. It took about 4 months. That means that was laid down to take 4 months. Parallel these simulator training, as I mentioned before, and then the parallel the shadow mode trainings. And well, we have 2 trainees now, ab initio trainees. They joined us in June this year. For them, it is easy. It is really easy because they came from the academy where they're training on a simulator, and that simulator works the functions of that simulator are very close to the RTC technology. So for them, it is really easy to handle that, and they do not have that change from a live tower to an artificial system. They're still in that artificial environment and do not have the change. So they start to train with that, and they don't have the problem that they have to get rid of some old behaviors from a live tower.
Okay, thanks, Andreas. A question also again for DFS, I think probably for Dirk. Do you envisage that remote tower technology can work at small airports with a large general aviation community with Class G airspace?
Please, can you repeat this question, the last part?
Do you envisage that remote tower technology can work at a small airport with a large general aviation community with Class G airspace? That's the question.
Yes, I think that was, I think, one of the challenges in Saarbrücken. Yeah, sometimes when I now review the project, I was thinking, is it not better to start an airport with less VFR traffic and less general aviation traffic? Could make it easier, perhaps, yeah, if you have only IFR traffic and some more huge aircraft. So I think it was really challenging to do it in Saarbrücken, where we have this issue that we have this mixed up of traffic. So next time, in my next life, yeah, perhaps I start at a different airport.
Yeah, this different airport. So do you have actually, one question is, do you have actually surveillance functionality in all of the airports? And I don't, that the question doesn't say if it's ground surveillance or general air situation surveillance.
Andreas, will you answer? Or should I
Sorry,
answer?
could you say that again? I didn't get.
Andreas, will you take over the response or the answer?
Yeah, I ask again, do you have surveillance functionalities in all the airports?
Surveillance for all the airports?
Yeah.
Yeah.
What kind of surveillance?
Everywhere
you're talking about the ground surveillance, or you're talking?
The question isn't specific on this one. So, but Dirk, you said yes at all 3 airports is surveillance. At least air situation display.
More or less everywhere surveillance, and we have everywhere a system. It's our so-called Phoenix system, where we see the air situation picture close to the airport. So we are equipped very good there.
Etwas verwirrend hier.
Let me see. There's lots and lots of more questions. An engineering technical question. So do you still have engineers, technicians based in Saarbrücken, and how is your remote tower center in Leipzig covered by engineering technical staff? I know as chief operations this is maybe not your area, but
yeah.
Would you like?
But I'm as well an engineer, so I can perhaps answer this question as well. Sure, we have there a service in Leipzig, responsible for all the technical systems there. And we have as well something like a remote service established, a remote technical service for some of the systems.
Okay. A question for Peter relating to the network. I'd like to combine maybe 2 here. So what is the contingency plan in case of the connection failure? And generally, what kind of long-distance network do you use for the voice and video data?
Yeah, basically, for the network connection itself, we are using a commercial WAN, but of course not only one, but two completely redundant and splitted WANs of two different providers. So basically, when one WAN would fail, then there would be an immediate switch over to the other one. Also, the voice communication is taking a part of those WANs. So here, if the video WANs are affected, then you still can communicate with the airport. And if really everything fails, then there are also operational procedures in place to handle that situation.
Okay. Another question for you, since you talked about multiple remote tower and multiple airports. There's a question relating to ICAO rules. With a multiple airport controlled by a single controller, assuming 3, how does that fit with current ICAO rules? Will the 3 airports operate on one frequency, or will it be different?
Well, in the CESAR project, we have evaluated like this, that of course on all three airports there are different frequencies, but in the center the frequencies are coupled. So basically, when the controller talks, he talks to all 3 airports at the same time, and of course he also hears the traffic from all 3 airports. Therefore, it's essential to have the voice integration in the remote tower system, so that they have a visual indication from which airport the incoming radio call is coming, and they have also changed a bit the phraseology, adding the airport name to the radio call.
Okay. A question to the screen setups, and it seems it's a judging question, but I'll just read it out, and maybe Peter and Andreas, you want to answer this. Why didn't you choose more ergonomic screens to show your tests? Have you also tried to turn to virtual reality for your air traffic control testings and operation? So the question is really about the screen setups and if VR was used.
Yeah. So basically, when we are starting a project, then the first phase is always a design phase, and in the design phase, we are designing the system together with the air traffic controllers. So basically, it's the decision of the air traffic controllers how they want to design their environment. And we have seen in different projects on the world that we have quite different setups. So the demand and the use cases and the environment for air traffic controllers in New Zealand is totally different to Germany. Although they are doing basically the same, but they have designed the different systems, and that's the reason why we have sometimes compact working positions with smaller monitors and maybe 5 screens, that we have sometimes very small working positions with even only three monitors, which is totally suitable for AFIS, for example, or that we have large video wall setup when it comes to larger airport operations where multiple working positions are in the front of the large video wall, and there the intention is that really it is ensured that all air traffic controllers seeing exactly the same picture. So that's how the screen design and the CWP design basically is done when we are offering a project.
So basically, what you say is it really depends on the use case which design is optimal. There is no one
exactly. So there is
optimal.
Exactly. So there is no standard solution. So for different use cases, different setups might be useful, and also for different environments. Think about if you simply don't have the space for a large video wall operation, then a smaller configuration would be more suitable for you. Also, you have sometimes the conditions that you have limited space in a tower cabin and you want to use remote tower technology as a vision enhancement, and then you place 3, 4, 5 smaller screens in the tower cabin, for example. But that's totally dependent on the use case and on the environment. The good thing is that we are providing a remote tower software which can be adapted to all these different screen setups and environments just by changing configuration. So there is no need to change the software itself, and that is beneficial when it comes then to regulatory approval and to certification.
Okay, thank you, Peter. A question to the traffic. I mean, of course, we know the traffic in Saarbrücken right now might be less, but we all started actually before the crisis, and we said beginning of 2019. So in terms of traffic that can be handled, in terms of the capacity that is available at the airport, has that changed when you operate the tower remotely? I don't know, Dirk or Andreas, who would like to go for that question?
I think
Please,
it's
Andreas,
a
take
very
over.
individual thing. Every controller has its own limit. And as I mentioned before, in the training phases, we had simulator runs to find out even that limit, this individual limit. And yes, of course, in the beginning it was a bit lower than it has been before on the conventional tower. But I think nowadays it's back to what it has been before.
So I'm just scrolling through the questions here. Do you have a specific remote tower simulator with all the functionalities of the remote tower? For instance, PTZ or infrared or simulated infrared. Is there some kind of simulator available? Andreas, I think that's for you again. I think you talked about the training before
there
and
is
the simulation.
Yeah, there's a simulator, and that has been at Saarbrücken until that day we left. And now it is installed at Erfurt for that training. The air traffic controllers of Erfurt had to go through these training phases, of course, now, before they come here. And the simulator can even be used as a simulator for Saarbrücken. That means even for our ab initio trainees, there is a chance to, especially now in that time, so during the Corona crisis and the winter, the beginning winter, where there's very low traffic, that they can train in an environment that is very close to the RTC, or that is exactly all the functions we have on the RTC working position we have there as well.
Okay, okay. Since you also see the questions, and there's a questions on top that is related to multiple airports and training, I'm not ignoring this question, sorry, but here we are speaking really about the case in Saarbrücken. I think this multi-remote tower, multi-airport setting is really good for another session, a specific session later on, where we go into the research. So I'd really like to focus the questions that are asked to the group here, which is available. One thing maybe, we've seen some bounding before when you showed us the working position, so there is a bounding around the aircraft. Are you also thinking about showing aircraft labels like the flight number, aircraft type, and so? And I'd like to ask Peter about that.
Yeah, so basically we have two prominent features within the remote tower solution. The first one is the bounding functionality. So the bounding functionality marks moving objects based on image recognition. So this is just to raise the situational awareness of the controller if there is some movement in an area where no movement is allowed or where no persons allowed, so that he basically can identify if there is a threat or not. The second feature is are the surveillance labels, and the surveillance labels are here. The position of the surveillance systems are matched to the positions in the specific out of the window view, so in the panoramic screens. And here it depends on the design phase together with the controllers. So there is a very simple version where only the call sign is shown, but of course you can also add additional data like the altitude, the heading, the speed, the type of movement, if it's an arriving and departing aircraft or a crossing aircraft. The only thing is, and that therefore the design phase is so important, is that you don't overwhelm the controller with too much information. So that's important.
Okay, coming back to the design phase, there's a question here as well on maybe for Andreas. In designing this, I mean, I know there has been certain iterations going forward in designing this. How did you end up with that choose and design of the working position? You have those 5 screens for the panorama, you have a couple of supplementary screens. How did you end up with that? I've seen other things, I've seen other tests, but why did you choose this one now?
Yeah, we tested a lot of other settings, of course. We ended with this setting because it is the best working ball for a single-handed tower, we thought, or we're still thinking. It's small screens, that allows that you get pretty close to them. On the other hand, you have, of course, the images are smaller. These screens are much smaller than the window screens of the conventional tower has been. And there is the danger that you lose the target, and therefore we have this bounding function that these targets are highlighted again. And well, it was just the setting close to the working position, close to the video screens, and the smaller screens, they have the advantage. Well, it's a question of fatigue. As long as you sit there, the more you get tired of the brightness of the screens. That smaller screens do not have that brightness, not that it allows you to stay there for 3-4 hours at once, and it doesn't really make you tired.
That's a really good point. The question of fatigue and always constantly have to observe and watch the screen. So I think it's a pretty good choice. I've been there sitting myself and looking at it, and of course when it was not operational. But it's really awesome, this setup. A technical question here. What level of design assurance has been employed by the software development to satisfy the safety case? I think it's
well,
pretty forward.
all our software is certified by ED 109 and ED 153 SOL 4. So here we have all this software assurance level to provide safe air traffic control. So that's absolutely necessary, and that's basically mandatory to have it in the software.
Okay. Question for DFS again. Is there a flight plan obligation for the remotely controlled airports, or how do you assure the predictability of the traffic? Andreas, if you want to answer that.
No, there's no, of course not. That is all the same as it has been before. You can come to that airfield without any flight plan, without any precaution, but just as it has been before. Just call in, and then VFR traffic is handled as the capacity allows, and or as traffic allows, and exactly the same as before.
Okay. Going to the regulations side again, the cameras and the screens, of course, there needs to be some level of performance requirements. Peter, can you tell us about these requirements? Are there, what do they say, and what is affected by the requirements here?
Well, of course there are performance requirements, but especially when it comes to the image quality of the camera, then it's always hard to define the right requirements, and therefore it's important to know that, for example, a high resolution does not automatically means a high quality of the picture. So what is effect currently today is that basically every high quality HD camera outperforms a 4K camera in detection range, and that's a safety topic, because what are you interested in as an air traffic controller? You would like to detect and identify airplanes and other objects which are far away, and therefore it's always a mixture of different quality parameters. So basically consisting of resolution on one side, but of course also the light sensitivity on the other side, the performance of the sensor itself. So there are multiple performance requirements, and it's not only one requirement. So basically, it has always to have some balance between the different quality requirements, because you have to consider that if you have a very high resolution and high quality picture at the airport, then you somehow have to transfer it into the center. And the higher the quality is, the more bandwidth do you use, and maybe you don't have the bandwidth in your country between the airport and the center. And if you are limited by the bandwidth, then it's important that you have a system which can be adapted to the available bandwidth, for example, so that you use the bandwidth in the most efficient way possible to transfer the highest possible quality from the airport to the controller working position in the center.
Okay. The next question talks about the integration of other manufacturers' equipment, and specifically it says here a new VCS system, for instance. Of course, I assume it means a new Frequentis VCS system, or at least I hope so. Okay, why else? So the question really is, as technology develops, would other manufacturers' equipment be capable of being integrated? And let's take some other equipment here.
Yes. So definitely yes. So what Frequentis has done in the past 5 years, we have developed a special integration platform called Mosaics, which provides a safe and a reliant environment to integrate different ATC applications, including the voice communication system. And since this year, all Frequentis and all the products out of the Frequentis family, including Comsoft and Atrix as well, are supporting that integration platform. But we are currently in the Danish project in Billund. We are also integrating, based on this platform, third-party suppliers, so that also other interfaces and other systems can be integrated in a safe and reliable way with this integration platform Mosaics.
Okay, and I'm seeing a lot of technical questions here. Thank you, Peter. But let's see, there is just one question coming in from a skill set point of view, from an RTC EDCO skill set. Are there any additional skills that are required to operate a remote tower center? And I think Andreas and Dirk, but Andreas, I think you can answer that. Is there something additionally?
I can answer very short and very clear. No. There are no further skills. No. As well, the training at the academy is still the same as for all other airfields as well. There's nothing special for RTC.
Okay. I could imagine that it's like new people coming in are getting, and also we are used to work more in a virtualized environment, and I think especially new people coming in would accept that as well pretty easily. So let's see, what are the other questions here saying? A technical question again, bandwidth requirement. I think this is the most asked question when we start talking about remote tower, and I fear there is no one answer to this, but bandwidth requirements. What's the take here?
Yeah, so basically you have to take care of the use case and the system. If you have limitation in the bandwidth, then of course the system can be designed to handle this bandwidth. As a minimum, I would say you have a bandwidth of about 20 megabit per second, so that's very limited, but maybe enough for a simple AFIS system, like we have the case in Akureyri in Iceland. So there we don't have more bandwidth, and we have adapted the solution exactly to that bandwidth so that we can use the bandwidth to transfer the highest possible quality. What we are working on currently is also to provide remote tower services via satellite. So with the new high bandwidth satellite constellations, it should be possible in the near future also to use satellite connectivity, especially in the case if you have only one wired provider to a location. Then satellite, for example, can be a redundant a redundant network to connect your airport with the center. But basically, so it starts at around 20 megabits, and then of course, the more bandwidth you have, the better it would be for the quality of the cameras and the quality of transmission.
Okay. Thank you, Peter. Looking at the time now, we have to really wrap it up. I think there's one more question that I can take here, and then I'd like to start to conclude it. This final question, or almost final question, I think that goes to Dirk, since you were involved in this from the very beginning. So what were the main success factors during the course of this project?
The main success factor was the early involvement of the air traffic controllers and the engineers. This was very, very important to get the right feedback at every stage of the project. The system was developed together with them in a very iterative process, and I think that this was very important. And when you look now at the result, sure, perhaps somebody of you expected something like a screen ensemble in a science fiction movie. What you see now is the hard work together with the air traffic controllers to adapt and to find a system which fits for purpose. And I think that was the most important issue. Yeah.
Thank you, Dirk. So a final question. Really, that's we have to conclude now. The time is almost over. And the final question for you, Dirk, also. What's the advice that you would give to airports and ANSPs worldwide? Advice now.
Yeah, be brave. That's a very good solution, I think, for the future. And it's from my point of view a game changer as well. Yeah, if we go in this direction with more and more airports, I think the first step is the most difficult one, and then it's will be more and more easier to implement the system and to train the people for these systems. And sure, be brave. Thank you.
Good statement, really, Dirk. I like that. Thank you. So with that said, I'd like to thank my expert panel here. Dirk, Andreas, Peter, awesome. Thanks for answering all these difficult, some of them difficult questions. I'm really sorry that I feel we could only answer like half of all the questions. So for that, I think we're gonna stay in contact. We will make the recording of this session available afterwards. You will see us next, actually, at the Global Airports Leaders Forum, part of the Dubai Virtual Airport Show on December 7 to 9. And also you will see us at the virtual ATCA annual conference, taking place virtually in Washington, D.C. It's taking place online, of course, December 7-11, where you also have the chance for a personal interaction with our experts. Peter will be there again. Our team from Frequentis US will be there as well. So this is the next points of contact. If you have further questions, if you think you want to have your questions answered, please send us an email. Contact your Frequentis or DFS point of contact in your area. You can also contact Peter Griedling or Yannick Bayer. You see the contacts here on the screen. And of course, if you like what you saw here, hit the like button, subscribe to our YouTube channel, check out our LinkedIn pages, our other YouTube videos from Frequentis DFS AeroSense, of course from DFS and also from Frequentis. And you can find us also on Twitter and on LinkedIn. My name is Markus Klopf, and it was my pleasure. It was a pleasure to be your host for today for this really, really exclusive preview and this exclusive look into Leipzig today. Thank you.